How do you solve and graph inequalities like the one you see in the corner right here? Well, the first thing you need to remember is the golden rule of inequalities. And the golden rule of inequalities says that whenever you multiply or divide by a negative number, you must flip the inequality symbol. So that's the biggest rule that we need to remember. So how do we actually solve them? We solve them just like equations. It's just that when we get an answer, we get lots of numbers as our answer instead of one number. So when we solve an equation, we get x has to equal this number, right? But when we solve an inequality, we can have an answer like x is going to be greater than this number. So it's any number greater than or this number, or any number less than this number, or maybe it's any number greater than this number and less than that number. So we get a huge range of answers for inequalities rather than just one number. But we do the same thing that we do with any equation. We get the variable by itself. We decide the direction of the shading for our answer. We circle the number on the number line. We choose whether we're going to use an open or closed circle, and then we finally shade. So when you find the answer to an inequality, you have to decide if you're going to graph it with an open circle or a closed circle. And the way you do that is you look at the actual inequality symbol that is in your original inequality. If it is a less than or a greater than symbol or a not equal to symbol, then those are going to be an open circle. So when you graph, you're going to have an open circle. If it is less than or equal to, greater than or equal to, or equal to, then we're going to have a closed circle. So I'm going to leave this example for you to solve on this side. We're going to solve the ones on the inside now. I'm going to solve and graph this inequality. So the very first thing we need to do is isolate the variable, right? Just like any other equation. So we're going to subtract 3 from both sides. We get negative 2 times x minus 4 is greater than negative 4. Now we added or subtracted a negative number, so we added a negative. So we're not going to flip the inequality symbol, right? Because we didn't divide or multiply. Now we're going to divide by negative 2 to get that all by itself. And since we did divide by a negative number, we're going to go ahead and flip that negative, the inequality sign. And that is 2. And then we're going to add 4. And in the end, we end up with x is less than 6. So this is our answer. So the answer to this is any number less than 6 will make this whole thing true. That's what we just figured out. So how do we graph this? Well, we're going to have, let's see, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so we decide what direction it's going to go. Well, it's going to go less than 6, so it's going to go to the left. Okay. Then we decide what if it's going to have an open or a closed circle. Well, we have just less than, not equal to, so we need an open circle. And then we're just going to shade to the left. And that's it. So any of these numbers here on this number line will make this true. All right, we're going to solve this one. This one's really tricky because it says x is either greater than this one or this one is true. So we actually have to do both of them, okay? So we solve this one by subtracting 12 from both sides, and we get 4x is greater than 32. We divide by 4, and we get x is greater than 8. Or we subtract 10 from both sides, and we have negative 12x is greater than negative 48. Divide by negative 12. And we flip the inequality sign. X is less than 4. So x is either greater than 8 or less than 4. So these are our two answers because this is an or problem. There's lots of times you're going to see them or like this where it says like these are two different things. And so we're going to graph that. All right, so how do I graph x is greater than 8? Well, open circle, and we decide the direction. Ooh, that went a little crazy there. That's the direction. And then less than 4? That's the direction. There you go. That's it. So it can be any number on either one of those shadings is going to make this true. We have an absolute value inequality now, and so remember with absolute values we have to isolate the absolute values. So we're going to subtract 1 from both sides. And we're going to get the absolute value of 1 plus b is less than 3. And so then what do we do now? In equations, we would just separate this as 1 plus b is equal to 3 and 1 plus b is equal to negative 3, right? But let's think about what absolute value really means. Absolute value means distance, right? So this means the distance from all of this stuff to 0 is less than 3. So if you think about that on a number line, where on a number line would the distance of some number be less than 3? So if this is 0, here's 3. If I'm over here at negative 3, if I'm anywhere in between here, then I'm at least or less than 3 away from 0, right? So to rewrite this absolute value inequality, I'm going to write that that 1 plus b has to be less than 3 or greater than negative 3, right? It has to be in between negative 3 and 3, because then that would make the distance of it less than 3. So let's solve that. This is a compound inequality, and so we are going to solve negative 3 is less than 1 plus b, and 1 plus b is less than 3. It's just two different inequalities. Subtract 1, and I get negative 4 is less than b, and then if I subtract 1 from there, I get b is less than positive 2, excuse me. So here we have that b is greater than negative 4 and less than positive 2, so we can graph that. Are they going to have open circles or closed? They're going to have open circles because they're both just less than or greater than, not equal to. And it's all of these numbers. So any of those numbers, if I put them in there, would make that true. Last, we have another compound inequality. So again, for compound inequalities, we just separate them. 36 is less than or equal to 11 minus 5x is one that we're going to solve. And then 11 minus 5x is less than or equal to 66. So remember, above here we had something that was an or. It was like either one of these is true. Well, for this one, both of them have to be true. So we're figuring out which numbers would make them both true. So I subtract 11 from both sides, and I get 25 is less than or equal to negative 5x. I divide by negative 5, and I get 25, flip the sign, is greater than or equal to, not 25. Negative 5 is greater than or equal to x. And then on this one, if I subtract 11 from both sides, I get negative 5x is less than or equal to 55. Divide. I get x, flip the sign, is greater than or equal to negative 11. So if you think about this on the number line, I got that x is less than negative 5 would make this true, and x is greater than negative 11 would make this true. So where are they both true? They both have to be true. Okay, so here I have negative 6, negative 5, negative 4, negative 3, negative 7. Okay, so greater than negative 11 would be this way, right? And then less than negative 5 would be this way. So where are they both true? They're both true right where they overlap, right? So from here to here, and we're going to do closed circles since they're greater than and less than or equal to, and right here. So these are the numbers that would make both halves of this true, which is what we want.